Hello and welcome to Medic in the Making. I'm your host and I'm just about to start my first year at medical school. After the past two jam-packed years, there's so much that I've learned about the medical application process, from the UCAT to personal statements to interviews, A-levels and everything in between. And now I'm here to share all that information with you. Today's episode is episode 1 in the medical interview series, and I'm going to be discussing medicine throughout history. In this episode, I'm going to be looking at sort of the headlines and the big changes that happened in medicine that were transformative and innovative. And before I started my interview preparation, this topic isn't one that I've thought much about because we're very focused on the now and the present. But I think actually if you can show an appreciation for the bigger picture, then it can translate to more authenticity during the interviews, and it can also mean that your knowledge within your own self, it feels a lot more secure because you have just a greater understanding of the background and general knowledge. In the dim and distant past, medicine often consisted of a few remedies made from plants, animal parts and crushed minerals, and they were often, these remedies were often administered by religious authorities or figures like priests and self-appointed medicine men. And it's quite difficult to pinpoint exactly, when we sort of transitioned from this and when medicine was born, and how that happened, because it was most likely an evolutionary process that involved lots of different people over many years and lots of different steps in between. However, Egyptian records show that Imhotep, at approximately 2600 BC, was the first recorded physician in history. And he was an important figure in ancient Egyptian medicine, and he wrote a medical treatise titled the Edwin Smith Papyrus. And for somebody at that time, this was quite an astonishing thing to have done. And this, medical treatise, it contained lots of different anatomical observations, ailments, and cures. Now, if you move on a little bit in history, you will come across the Greek physician Hippocrates between 460 and 370 BC. And he was considered by a lot of people to be the father of medicine. And the reason for this mainly is because he laid down the foundation for the logical or the rational approach to medicine. He got rid of this idea that illness or disease could be spiritual, and he instead chose to explain, diseases and illnesses as a result of the environmental factors like, your habits, where you're living, your diet, etc. However, his theories were not based on correct anatomy and physiology. And one of these incorrect theories was known as humorism. And this is something that, if you look in history, it's a concept that was, very common at the time, and you'll probably come across it a lot if you look back in time. But this theory essentially, it was made up of the idea that as humans we have 4 basic substances called humours, which when they're in balance, a person is healthy. And the 4 humours were believed to be black bile, yellow bile, phlegm, and blood. And it was believed that all diseases and disabilities resulted from either having too much or too little of one of these 4 humours. And a deficiency in one of these humours could be, as a result of vapours that were inhaled or absorbed into the body. And this theory of humorism, it dominated the Western world for more than 1,300 years. Now, despite obviously this incorrect anatomy, Hippocrates and his followers, they were the first to describe many diseases and medical conditions. And in fact, Hippocrates is given credit for the first description of the clubbing of the fingers, which is a really significant diagnostic sign in diseases like lung disease, lung cancer, and heart disease. And sometimes that is why you may hear clubbed fingers being referred to as Hippocratic fingers. Hippocrates is also most famous for setting out, the responsibilities and the duties of a doctor in what is known as the Hippocratic Oath. And some of the things that the Hippocratic Oath includes is, the idea that access to healthcare should be free, that doctors should always act on the principle of beneficence, which means to act in the interest of the patients. Also the principle of non-maleficence, which means not harming the patient, and the principle of confidentiality. And what's the Hippocratic Oath? It's now outdated, and you can find the entire Hippocratic Oath online if you go and search for it. But what's the oath itself is outdated. A lot of some of the principles that are sort of in that Hippocratic Oath, they're still valid today, and you'll still see some links between that oath and the premise of the GMC's medical council's good medical practice and the duties of a doctor. Now, if we move on to the Roman Empire, we'll come across a very famous Roman physician, also of Greek descent, by the name of Galen of Pergamon, and this was between 129 and 200 AD. And he was recognised as being one of the best surgeons of the ancient world because he had performed brain surgery and eye surgery, and he also clarified the anatomy of the trachea, and he was the first to demonstrate that it's the larynx that generates the voice. He was also the first person to realise that there's distinct differences between venous blood and arterial blood, with venous blood being darker and arterial blood being brighter. And he also explained the difference between motor and sensory nerves and discussed the concept of muscle tone. Now, moving on to the Middle Ages, a lot of the works that were written by the pioneers of medicine were translated into Arabic, and they were used by Islamic physicians in terms of for medical research. And physicians like Muhammad ibn Zakaria Razi, also known as Rhazes, started questioning how true the humorism theory was. And Rhazes, he was a prolific author. He wrote many books, over 200 books, and he was credited for being the first person to figure out the difference between smallpox and measles, and also to discover a lot of different compounds and chemicals, including alcohol. And he also introduced the idea that even really highly educated, intelligent doctors didn't have the answers to all medical problems, and he advised that practitioners should keep up with advanced knowledge by constantly and continually studying medical books and keeping up to date with new information. And the 14th and 15th century also, during the 14th and 15th century, there was also a major shift in medical thinking, whereby people started to reject the traditional authority approach to medicine. And the traditional authority approach to medicine was that if someone in authority had said something in the past, then it had to be true. And we moved away from the traditional authority approach to a more evidence-based approach in the 14th and 15th century. Now, in the 16th and 17th century, there were lots of really significant medical breakthroughs. So the Italian physician Girolamo Fracastro, he suggested that epidemic diseases, might actually be because of things that are outside of the body that could be transmitted by direct or indirect physical contact. And he actually also introduced new treatments for diseases like syphilis. Then, in 1543, the Flemish scholar Andreas Vesalius wrote the first complete textbook on human anatomy, and much later, in 1628, William Harvey explained the circulation of blood through the body in arteries and veins. And previously it was thought that blood was as a result of food and was absorbed by muscle tissue, but obviously this wasn't the case. And during the 16th century, Paracelsus discovered that illness was caused again by things outside of the body, like bacteria, and not by imbalances within the body. Now, the French army doctor Ambroise Paré, born in 1510, revived the ancient Greek method of tying off blood vessels. And after amputation, the common procedure actually was to cauterize the open end of the amputated appendage to stop any hemorrhaging. And this was the way that they used to do this, was by heating oil, water, or metal and touching it to the wound to seal off the blood vessels. And Paré also believed in dressing wounds with clean bandages and ointments, including one which he made himself, composed of eggs, oil of roses, and turpentine. And he was one of the first people to design artificial hands and limbs for amputation patients. And on one of the artificial hands, the two pairs of fingers could be moved just for simple tasks like grabbing and releasing things, and the hand looked perfectly natural when it was underneath a glove. Then the Englishman William Harvey also described the circulation of blood around the body, and he found that blood was pumped around the body by the heart. And later on, two physicians, Richard Lower and Robert Hooke, also showed through experiment that blood picked something up on its way to the lungs, which turned its colour to bright red. And only later on in the 18th century, the French chemist Lavoisier discovered oxygen. And Lower also performed the first blood transfusion from one human to another human. Now, there was another man he was a Dutchman, and his name was Anton van Leeuwenhoek, and he invented the microscope and went on to discover red blood cells, bacteria, and protozoa. And in Italy, a physiologist by the name of Marcello Malpighi used the microscope to study the structure of the spleen, the lungs, the liver, the skin, glands, and brain. And several microscopic parts of the body, for example, a skin layer and parts of the spleen and kidney, are named after him. An Englishman, Thomas Willis, discovered the presence of sugar in the urine of diabetics, and he was just a pioneer in research into the anatomy of the brain, the muscles, and the nervous system. And he also invented the term neurology, and he recorded the anatomy of the brain and nerves in really accurate, specific detail. And he was the first person to number the cranial nerves in the order in which that they are now usually counted by anatomists. The 18th century was a really good century for breakthroughs in diagnosing, and the Dutch professor Herman Boerhaave started making continuous systematic use of the thermometer to monitor and check body temperature. And the Austrian physician Leopold Ornbrugger discovered the need to sort of tap on the chest to look for fluids inside of the lungs. And the 18th century also saw some pretty amazing advances in therapeutics. And for example, the English surgeon James Lind showed that scurvy, which is a vitamin C deficiency disease, could be cured by eating citrus fruits. And the botanist William Withering demonstrated how effective the effectiveness of digital is in treating heart diseases. Additionally, a British country doctor, Edward Jenner, developed the smallpox vaccine, which was so successful that smallpox has now been eradicated from the world. However, even though all of these discoveries and these breakthroughs and advances happened, there was a really big gap between the new discoveries and the practice of medicine, in day-to-day life. And the main treatments still revolved around cupping, bleeding, purging, and following the old Greek tradition. And syphilis was treated with really, really large and often fatal doses of mercury. And a lot of physicians were hesitant to adopt, new ideas, and, quote unquote, serious physicians like William Harvey even said that they had lost patients because of trying out new techniques. Now, in the 19th century, after a lot of hesitation, that is when medical practice finally started to change, and a major improvement to the microscope made it possible to study tissues and cells in even more detail, and it led to the new science of cells known as cytology, and cell theory, which basically outlines that all living things are made of cells, and that cells are the basic unit of life and they are made from other cells, is one of the cornerstones of modern medicine. And there was a German scientist, Rudolf Virchow, and he used cell theory, and he demonstrated using cell theory that changes in cells can cause diseases like cancer. Now, another cornerstone of modern medicine was germ theory, and in the past, some advocates of humorism instead of medicine recognized, even though it was against their belief, they recognized that some diseases may have been spread because of contamination. However, generally speaking, most physicians believe that diseases causing germs appeared, randomly, spontaneously, and this belief it lasted from Aristotle all the way into the 19th century. But this belief actually changed when John Snow, the English physician, traced the source of cholera to water contamination by sewage. And then shortly after this, there was a French chemist, Louis Pasteur, and he ran some experiments. And these experiments came to the conclusion that life couldn't spontaneously be created. And Louis Pasteur showed that there were, in fact, organisms everywhere in the air. And he did this through an experiment which turned milk sour. And then he went on later to come up with a process that heats milk to kill the microbes inside milk. And we today refer to this process as pasteurization. And his further work on microorganisms also led him to come up with vaccines against anthrax and rabies. And germ theory was implanted within medicine by a German physician named Robert Koch, who identified that specific bacteria caused by anthrax, tuberculosis, and cholera. So he identified the specific bacteria that caused anthrax, tuberculosis, and cholera, and he developed a set of rules to figure out whether a microorganism was a sort of disease rather than simply being present. And this was sort of the beginning. This is where the science of bacteriology or microbiology stemmed from. So two more significant discoveries within the 19th century were anesthesia and antiseptics. Now, in sort of the mid-19th century, there was a Hungarian physician known as Ignaz Semmelweis, and he realised that infections that were happening in the obstetric units after childbirth were most likely due to bad hand washing by physicians. And in the late 1860s, there was a British surgeon, Joseph Lister, and he really helped to bring down the death rate from gangrene by dipping bandages and ligatures into carbolic acid and then pouring the acid into wounds to sterilize them. And this started, this sort of was really the start of antiseptic surgery. And now finally, we're moving on to the 20th century. Now, there was a lot that happened in the 20th century. Now, towards the end of the 19th century, there were really big efforts that were made to understand and to figure out the chemical composition of plants, and then to, from that knowledge, to then move on to synthesizing drugs. So, for instance, aspirin, which is a synthesized version of acetyl salicylic acid, was first isolated by Felix Hoffmann, who was a chemist with the German company Bayer in 1897. Now, in 1909, another German scientist, Paul Ehrlich, he synthesized the arsenic-based compound salvarsan, which was the first effective treatment for syphilis, and he therefore created the first antibiotic. Later on, in 1928, Alexander Fleming spotted mold growing on some bacterial samples in his lab, and as a result, he then discovered penicillin. Now, tests carried out during World War II showed that it was effective against anthrax, tetanus, syphilis, and pneumonia. However, penicillin was hard to produce on a massive scale, or mass produce, and as a result, it wasn't widely available until 1944. In 1943, an American biochemist isolated streptomycin, which proved to be effective against tuberculosis. And other discoveries included vaccines against tetanus, influenza, smallpox and polio, which led to the eradication of polio by the end of the 20th century, measles, chickenpox, human papillomavirus, causing cervical cancer. And other discoveries also include cortisone, which is a steroid hormone to reduce inflammation and suppress the immune system response, the contraceptive pill in the 1960s, the first antiviral drug to combat herpes, and the development of antiretroviral drugs to combat AIDS. Also, in the 20th century was sort of the rise of technology. So at the in the very late 19th century, the German physicist Wilhelm Conrad Röntgen discovered X-rays, and this made it possible to look at, the internal organs of the body. And in 1901, a Dutch physiologist, Willem Eindhoven invented the first electrocardiograph. And successive inventions came later, which allowed physicians to observe the body in a non-intrusive manner, which included ultrasound imaging, computerized tomography or CT scans, PET scans, and MRI scans. Now, in the mid-20th century, the heart-lung machine was developed, which created an artificial way to keep patients alive while surgeons were operating on patients. Operating on the stopped heart. And the cardiopulmonary bypass allowed major heart surgery to become a more routine procedure. And the 1970s saw the invention of flexible endoscopes, which allowed the introduction of laparoscopic surgery, which we often refer to as keyhole surgery. And in these kinds of operations, the endoscope, which carries a camera and a laser, is inserted into a tiny incision, and it's commonly used for procedures on hernias, gallbladders, kidneys, and knees. Also, in the 20th century was the use of artificial organs. So because there weren't that many organs for transplants, it sort of encouraged the development of artificial organs. And the first artificial kidney, which was used for hemodialysis, was invented in 1913, and that allowed sort of life to be prolonged for patients that had kidney failure. And artificial hearts were first implanted in 1982. Now, prosthetics. So although artificial limbs have existed for a very long time, the discovery of plastic sort of in the mid-20th century and other advanced material like carbon fiber meant that we could create devices that operate by electronic attachment to muscles. And some of the more sort of advanced devices that we're seeing now are controlled by microchips. Now, moving on to computers. So computers have made a huge contribution to medical advancement, and they don't just play a key role in scanning technology. They also run machines in theatres and intensive care units, and medical, obviously, records and prescriptions can be handled electronically, and researching data and all these things are also analysed on computers. And again, mapping the human genome wouldn't have been possible without the vast power that computers offer. And also in the 20th century came a better understanding of the immune system. So although immunization, it was practiced, in ancient China, and it was also introduced to the West by Edward Jenner, no one actually understood how it worked and the science behind it until the 20th century. So in the 1880s, there was a Russian biologist, and he discovered phagocytosis. And phagocytosis is probably something that you're all familiar with, because it's something that you learn at GCSE biology. You also learn it at A levels, but it's obviously he figured out phagocytosis because of his experiments on the larvae of starfish. And he realized that this process of digestion in microorganisms was essentially the same that is carried out by white blood cells. And his theory was that there were specific white blood cells that could engulf and destroy harmful bodies like bacteria. And this theory was actually met with a lot of hesitation and skepticism from some of the leading scientists. And at the time, most bacteriologists believed that white blood cells ingested pathogens and then spread them further through the body. And then less than 20 years later, Paul Ehrlich argued that the chief agents of immunity were in fact antibodies, which are obviously the proteins that are produced by cells and released into the bloodstream. And now in the end, both theories ended up being correct, but the massive sort of complexities of the immune system, we're continuing to learn about that today. Now, the progress in immunology also included identifying a class of disorders known as autoimmune diseases, where the body is basically attacking itself, like type 1 diabetes, lupus, muscular dystrophy, rheumatoid arthritis, and a range of drugs to go with them, which are known as immunosuppressants. And these immunosuppressants are really important in making sure that transplant patients as well are able to retain the organs that were transplanted into their body. So that allows organ transplantation to be, quite a routine procedure, and it allows it to be a viable surgery. So that virtually, the organ of any body can be transported from one person to another, obviously depending on different factors. And immune therapy also offers hope in the fight against certain types of cancer. Now, in the 1980s, the identification of the HIV virus brought the science of immunology again, back to the forefront of medicine. And the HIV virus, it destroys the immune system and therefore the body's ability to respond to threats. And we don't, have a cure for HIV or AIDS, but there exists like a range of treatments that help patients reach a normal life expectancy, and it's no longer, AIDS is no longer the death sentence that it used to be. Another one of the really big topics in the 20th century was genetics, and knowledge of the DNA structure made it possible to figure out the location of each gene. And by the early 21st century, scientists had mapped the genetic structure of humans, so what we refer to as the human genome. And figuring out, cracking the genetic code has also allowed us to introduce testing for diseases that are caused by defective chromosomes, like Huntington's disease, cystic fibrosis, and certain types of breast cancer. And it's also allowed us to create new drugs that are derived from natural body chemicals like insulin and the human growth hormone. Now, from a genetic perspective, one of the biggest research opportunities is gene therapy, which would allow the curing of disease by inserting sort of normal copies of abnormal genes directly into the cells by means of a virus. And you'll learn more about this if you do AQA, A-level biology. But the progress in this particular field has been very limited. Now, that is the end of episode 1. Thank you so much for listening. If you'd like to check out my other social media platforms where I have lots more information to do with the medical application process, then you can find me on TikTok and Instagram. My handle is medicinthemaking.uk, or alternatively, you can email me on medicinthemaking.uk@gmail.com. See you soon.